Yeah. Hi, Daniel. Welcome to DEALITT podcast, where we like to invite head of companies, CEOs, and scientists and professional people like you. Daniel, you are Associate Director in Geotechnical Observation. So, Daniel, how are you doing today, if I can start it?
Yeah, I'm very well. Thank you. I'm very happy to be here and trying to contribute, to give my little contribution to this. I think is a very good initiative. And yes, at the moment, I am really trying to find where the British summer has gone.
Yeah, hopefully it is
hopefully
going to come
at some point.
Yeah.
At the moment, I'm in Devon. It's a beautiful part of the British Islands, which is also a very interesting place from a point of view of geotechnics and geology, if I can say.
Yeah.
It's really amazing here in Devon.
It is.
So it's a very special place to me and to many civil engineers, I suppose.
Really nice to meet you, Daniel. Really nice to meet you. Hopefully we can contribute something today and really want to involve in your experience. Daniel, you have a high experience in observation, geotechnical observation and geotechnical monitoring system. And you are involved in different underground projects. You have also experience in underground tunneling. And I would like to learn from you a little bit. We would like to learn from you. So how do you feel after this great experience in underground monitoring system and geotechnical observation? If I kind of started.
Yes.
It's a long journey, I would say.
It is. It's a very long journey. I think, so I'm not sure I would really define my career as long or full of great achievements, to be honest. But I think looking back, I think I can say it is true that I've been lucky enough, in a sense, to be able to be involved in several different aspects of civil engineering. Tunnels are definitely one. And I have very fond memories of my tunneling projects, all of them. But I think if I can find, a common denominator in my experience is that I think I have always tried very hard to enjoy myself in really understanding how things work, and also to find the most efficient and maybe the most interesting, in a sense, from an engineering point of view, the most interesting way of actually modeling how they behave. And I think from this point of view, yes, tunneling and dams, but mainly from my experience, tunneling is one of the most challenging and fascinating among all of this, because they're very extremely complex and they are really there's everything in them. There is every sort of aspect, from structures to geotechnics, which you can really dream about. And of course, the more challenging geotechnical and geological settings you have, the most interesting it is, and the more nerve-wracking it is, in a sense. Yeah. But yeah, it's really it's fascinating, and yes, I think in my career I managed to enjoy myself as much as I could, really. Which
makes you really interesting and really contributing a lot to this topic. I would like to dive with you in really different questions, but I would like to start asking this question to many people. How do you manage your time, and what do you like to do in your free time? If I ask, I know it varies from person to person.
Yes. Yeah. So of course, no. I am very much, I think, a voracious reader. I read a lot. I always used to. I think I read mainly novels, but also history books, and mainly with a significant fascination for Middle Ages and World War I. I know it's an odd mix, but that's what it is. And also, I also go hiking as much as possible. I was born and raised in Italy. And I used to hike in Italian mountains, and especially the Alps. But also here in the UK, I do it a lot. Recently, I have developed a lot of interest together with my family in fossil hunting along the coast of the UK, and that's one of the reasons why I'm here in Devon. So yes, it's both a work and leisure in a sense. But yeah, that's pretty much me in a nutshell, I think.
A lot of things. You're busy with a lot of things. Daniel, if I can ask you this question, you're interested a lot in geotechnical observation and geotechnical monitoring, geophysics. So if I can ask, why you're interested in this subject? I know it's very interesting. What attracted you to this subject?
Yeah, so as I said before, I think I enjoy very much trying to understand how really things work, and mainly in terms of structures and geotechnics, in terms of structural and geotechnical assets. And from this point of view, geotechnical monitoring, but actually monitoring in general, is quite interesting because, of course, if you get adequate data and you do an adequate data interpretation and data analysis, then you have a lot of insights in terms of how slopes really behave in real life, and how embankments and dams and tunnels and all the assets really behave. And of course, then also how their construction impacts their surrounding environment in terms of course, the groundwater, for instance, but also existing assets as well. So you actually see a very complex picture from if you look at the right data in the right way, you see a very complex and very fascinating picture. And of course, the challenge is to start from a model, because that's how we engineer always work and how really science works. But then you need to really keep an open mind about what the data will tell you, because the data are supposed to be a if they are proper data, they're actually a representation of how really things work, independent in a sense of your model. And of course, if you keep this open mind, then the data will help really a lot in terms of enhancing your understanding and to enhance the models themselves, because you're actually able to improve the models on the basis of what you really see. Or maybe you realize you need another model because your one just is not good enough for that specific case. Or maybe you just can find a better one. And that's something you can still realize looking at the data. And of course, then the next challenge, which we are delving very deep now, but another challenge is to find a way to gather the right data, because the data are only useful when they are meaningful, so they need to mean something, but also when they're trustable. So whoever uses the data needs to be confident that those are actually representing reality. And all of this requires really quite a lot of skills. And two of the main skills is really a good grasp of how the instruments really work or don't work, and a deep understanding of the geotechnical and structural models and the maths and the hypotheses, because then if you have a grasp of both the theory and the practice side of things, then you can really make the best of the data. Sorry. So that basically, in a sense, what really interests me.
A lot of it is an interesting subject, honestly, and each process, as you say, a lot of challenges, we need to understand it. I would like to go a little bit deep with the case study, because you involve in different interesting project, Daniel. Starting with speaking about Crossrail 2. Crossrail 2 is really big project. You have involved in this project, and we learned a lot about this project. If I can ask the first question, what are the challenges that you face in Crossrail 2, and what lesson can be learned in the future project? So it's two questions in one. I know that challenges and the lessons. Yeah.
So I think Crossrail, first of all, was a great project to be involved with. It was the first project I was involved with when I moved to the UK. Of course, it was a really huge project, and it was a very complex project. And it involved, I was involved personally with the monitoring aspects of the mechanized tunnels and of the more traditional tunnels, what they call SCL here in the UK, which is sprayed concrete lining. And I was involved with both. And it was, of course, extremely interesting and also nerve-wracking, as I've said, because of the amount and complexity of the interfaces between the tunnels and the existing assets. Because, of course, the existing assets, in London included buildings, listed buildings, existing tunnels, existing utilities, So it was really quite complicated in terms of understanding, but also in terms of management, because it was again a lot of different kinds of interfaces, and also there were compensation grouting work. So as the tunnels were being excavated, the compensation grouting tried to minimize the settlements induced by the tunnels. So it was really quite a complicated environment, and there were many challenges, which is of course this is what it made it interesting. For instance, the planning needed to have the right monitoring instruments installed at the right time, in the right place, and measured correctly.
It's not easy. It's not easy.
No, exactly, because then that would allow the tunnels to be excavated safely and on schedule. So it was quite critical. But also another challenge was the reporting and the analysis and interpretation of the data, which was of paramount importance. And of course, with such a huge amount of data, it was really not easy to find an effective way of reporting and communicating the results. So, I mean, both the complexity and the sheer amount of data was quite complex to manage in terms of then providing an accurate picture and an understandable picture of what was really happening. But I think, at least for the sites I was involved with, this was really well achieved. And the monitoring data provided a lot of value for the project.
That's true.
And I think one of the main lessons really was lesson learned was the huge importance of a cooperative environment. I mean, there was this, whatever we've done, wouldn't have been possible without a constant cooperation and coordination between site, the monitoring team, and the engineering team. This engagement was not continuous and really strong, and was based on it was with a significant respect one for each other, but also respect in terms of personal respect, but also in terms of professional respect, and it was very much fostered by meetings and with proper forms of interaction. So it was a really good experience, but challenging.
A lot of challenges and a lot of lessons to be learned you have mentioned in this project. If I would like to stay speaking about this project, one of your research paper that you have contributed in speaking about 3D BIM model is really, and 3D BIM model in Crossray 2, it was a must. You have mentioned that there was a need to do a 3D BIM visualization for the project, and there was a need for the 3D printing. This was a proposed solution to address the discrepancies between the design data and also the surveying data by the contractor. So if I can take it as a question, do you see BIM model addressing the being improved to include monitoring data until now? How do you see this?
Yes, I mean, from a point of view of someone like me who's been involved in monitoring for a lot of time now, the idea of linking data with other data and with assets on a 3D model is really where we should be heading. It's a must do, because of course they would enhance a lot your understanding of the data themselves. Because if you can say, okay, these are the data and this is where they've been taken in a 3D environment, then of course you are much more able to understand what is really happening instead of just seeing points on a map or even just a spreadsheet. So actually, I think, as we always say, monitoring is not only about the data, it's also about the metadata. So all the data which allow you to understand the data better. And from that point of view, the idea of the building information modeling, the BIM, is central. I think, from my point of view, I think BIM shall include the monitoring data associated with the asset, but not only in terms of construction, also in terms of operational life. And to be honest, I think we already have the tools to do it. I think, or at least we are very close to have the tools. What we still need, I think, is the industry, in a sense, to properly embrace this kind of transformation. Because, I think, from my point of view, at least, there is still a lot of confusion about what BIM is or should be. Most people think it's just a 3D model, which is not the case. It's much more than that. It's supposed to be much more than that. So I think we need somehow still, we are in the process of having a cultural transformation, in a sense. We are not still there. No, not in the construction industry, at least, I think. But there's hope. There's hope.
Hopefully, yeah. Daniel, if I can please, because your experience involved project inside the UK and outside the UK. So if I can, you have involved in the project outside the UK. One of the project is Warsaw Metro Line 2. So if you can take me through the challenges and lessons that have been learned in these projects. I know there are a lot. Experience a lot.
So that was a very interesting project. It was the first point was that that was mainly deep excavations and tunnels, and the tunnels were not all of them, but most of them pretty shallow. So which makes tunneling much more difficult. So and it was a very complex geological situation. Also because there were not many records. I mean, Warsaw was basically destroyed. I think 97% or 98% of Warsaw was destroyed during the war, the World War II. So there was informations which basically were literally missing. It was not always easy or not even always possible to gather them. So it was really a complex one from a point of view of monitoring, but really from a point of view of engineering, there was many challenges there. There were groundbreaking works actually, like the use of cement injections to basically create some kind of arches to protect buildings from the running tunnels. But also there were I was working in a joint venture, which was a joint venture between an Italian company, a Polish company, and a Turkish company. So of course there was time and energies. Yes, they're definitely different, kind of approaches to projects. So there was part of the of the efforts were made to build a team which could actually work together from so different experiences. So it was. I won't say communication was a challenge, but definitely was, in a sense, was something to be taken care of. Which was.
I see. That's really great. That's really great experience. I think it's really different experience than the UK. Different system, different process. It's different geology, different geology, different type of tunnel system. Then, if I can ask a question that is related a bit to the management. And the management tunnel is really different world. I want to ask a question that related to communication. Communication in the civil engineering is really important. If I can ask this question, we built a system that helps us to capture data, managing data, and save informations. So, what are how do you see the communication and being improved, and also what are the challenges of the communication during the industry? Do you see it? What are the challenges of the communication that you see it during the project that you're involved in?
So first of all, you're right. I mean, communication is a fundamental challenge, especially when the projects are large and complex. And this is mainly true for geotechnics and for geotechnical monitoring even more. Because one of the main points is to try and communicate the complexities, really, which are many, around geotechnical modeling, first of all, and even more, the interpretation of the geotechnical monitoring data. Now, geotechnical modeling is normally complex because, as you know very well, because there are fundamental uncertainties associated with the ground. And of course, because in generally, geotechnics deals with at least two continua rather than just one. So there's always, at least in our climates, there's always the soil and the water together. So, and this already is a complexity in itself. But of course, this means that the interpretation of geotechnical monitoring data is naturally complex by default. And then this is because it needs to take into account, when you interpret, you need to take into account the complex behavior of the ground, which is complex by itself, and which is even more complex because of the groundwater. And then you have all the uncertainties associated with the modeling itself, or the parameters and so on. So communicating all of this is obviously very complex, and then there is desperate need, I think, in terms of software, really, to do this kind to undertake this kind of communication. Now there are adequate softwares which is starting to be developed and becoming available on the market. However, the idea of integrating monitoring data within normal engineering practice is not really yet common practice. So, which is a shame, I think. I'm biased. I know I'm biased, but I think one of the reasons why we don't really do this on scale, in a sense, I think is because one problem is still that the figure of the monitoring specialist, and maybe even the geotechnical monitoring specialist, is not really well recognized yet as a professional figure. with its own skills. But again, in general, I think we are going in the right direction. Sorry. I mean, I think in terms of communication, we have to recognize that for geotechnics and geotechnical monitoring, the communication is complex, and then we need adequate softwares to do this. And the development of this software, which shouldn't really happen in terms of software developers, but should really happen between software developers and geotechnical engineer together to actually create something which communicates effectively.
Communicate all the process, that's really
exactly
important.
The process and the complexity, correct.
That's really important point, I think. Then I would like to ask you something a bit related to, or a question related to the geotechnical observation process. For the geotechnical observation process, we do have different stage. You know more than me, of course. Starting with justifying the why we need this instrument, justifying the data, also justifying the locations, the data interpretation, after that the decision making. So if I can ask you the question, what are the key challenges of the geotechnical observation process? It's a lot.
There are many.
From where to start, but it's good to take it from practical experience, I would say.
Absolutely. So there are several significant challenges. You're absolutely right. One is definitely cultural, as I said, in terms of actually accepting the monitoring data as part of the engineering process, not just the model, but really to understand the data are part of it, from the design stage to actual the operational life of the asset. And I think in this sense, the academic world could and should do more to address this, because again, I think initially the problem is cultural. We are taught at university to think through models, which is correct, but it's not only that. So data have their own status and their own importance, and their integration also is very important. And another challenge is really to start asking the right questions. First and foremost, what do you want to measure? And then after that, how do you intend to use the data? And these are very fundamental questions, and this is something a monitoring specialist should really be doing. And equally important, in a sense, are the challenges associated with the procurement of the monitoring system. This is, I think, is very central to our industry today, because monitoring systems now, mainly, not always, but in the most cases, they tend to be procured trying to minimize the cost of the instruments and of the installation of the instruments. But the problem is that is not where the value is. The value is not in the instrument. The value is only is in getting meaningful and trusted data. Because then if you have data, which the value is in data, because then the data, you use the data to take decisions, to take action. So the value is not really in the instrument, the value is in the data that you can get. And this is really the challenge, because if you start trying to procure that through minimizing the cost of the instruments, you are associating the cost to the wrong thing. Exactly. So the impact of the decisions you take and the opportunities and the de-risking associated with having meaningful and trusted data need to be communicated to all parties, really, including the contractors, the subcontractors, the client, the designers. So it's not really about I need an instrument. No one needs an instrument. What you need are data, but you need those data to be meaningful, and you need to have those data so that you trust the data, because otherwise, again, the whole value of the thing is zero. So that's, I think, and gaining meaningful data starts really with an adequate definition, scoping of the system. So really is about plus procuring the right instruments. It's a complex process, and this cannot really be achieved without adequate cooperation and coordination at all levels. And this is really a task for the monitoring specialist, I would say, as well. That's what it is.
That's why we need people like you. I would like to ask a question that now it's booming for the industry, which is machine learning and AI. So machine learning now has become part of many companies, you know that, and we are use it, and we keep using that. So if I can ask the question, how do you see AI improve the data interpretation in the observation? Data interpretation, how do you see this?
I do think that there are huge opportunities for AI to support data analysis and interpretation from a monitoring point of view. However, we always should take into account that, we should always remember that the correlation does not really imply causation. So, and any output based on data depends on the quality of the data. So this means that, and on the meaningfulness and the trustability of the data. So this is particularly true in complex and uncertain situations, which are quite common in geotechnical engineering. So definitely, yes, is something we should embrace, absolutely. But again, we have to focus on the meaningfulness of the data we use to inform AI.
Nice. This is really important point, I think. Coming to the research, I think there is a need for research for the observation. So if I ask from your practical experience, what research need to be highlighted, if I can ask this question?
I think there are a number of fascinating subjects that could be explored, making use of the right field monitoring data from a researcher point of view. I think really there could be some more research efforts dedicated to find practical and effective ways of integrating field monitoring data into the management of geotechnical assets during their life. So in terms of optimizing the monitoring systems to optimize the inspections, the maintenance schedule, and even the maintenance interventions. Because if you know how your asset is performing, then you know where you need to intervene, when you need to intervene, which means that you can then optimize your resources, because you have every asset owner has a limited amount of resources. So you need to understand how to use those effectively. And taking decisions based on real data, then you can do that. And this is of particular interest in terms of the current socioeconomic challenges posed by, for instance, by climate change.
That's a really interesting point, I think. Daniel, if I can ask a final question. I would like to ask many other questions, but we don't have time. Daniel, if I could like to ask a question, what is your advice for the engineers who are interested in geotechnical observations or would like to join the industry new?
I think this is the advice I would have given to myself. I think stay curious and always keep an open mind. I think especially for geotechnical engineers, but for all engineers really, we must remember that the best thing that soils and structures and rocks, what they really do best is not to care about our models. They don't really care about what we think, about how we think our models are good or not. They don't really care about our assumptions, our coefficients. They don't know any of that. So field monitoring, I think, is a truly fascinating subject because it offers a glimpse on how geotechnical assets and the soil in general really works. However, it is also a complex and challenging task. I mean, there's no way of hiding that. And this requires a number of skills, from theoretical knowledge of the soils and the soil mechanics and the structural mechanics, up to data analysis and detailed knowledge of the working principle of the real instruments, and even so much more than that. And so it is a field in which you will really never stop work, nor stop learning, really. I learn every day. And sometimes it's frustrating, yes, but it's really, at the end of the day, I think it's really fascinating. So
that's really important. Thank you, Daniel, for your contribution. Thank you for your time. Really happy to meet you today. And thank you, everyone who are watching us in DEALITT podcast. Please leave your comment, and we will come back to you for sure. Thank you very much, Daniel. Thank you very much.
Thank you. Bye-bye.
Thank you very much. Bye.